Welcome to cryptography class. Today's topic is Elgamal Cryptosystem. It is one of the randomized public key encryption mechanism. This algorithm is most relevant to Diffie-Hellman key exchange algorithm. In this Elgamal cryptosystem, the discrete logarithm methodology is used for calculations of encryption and decryption side. And the main applications of Elgamal cryptosystems are for sharing the session key in a secured way and for transferring a message in an encryption format. For these two applications only, Elgamal cryptosystems are used. This is the overview idea of public and private key generations, encryption and decryption methodology which will be done at an Elgamal cryptosystem. So here Alice is an initiator, Bob is the responder. And what are all the terms that should be necessary for implementing Elgamal cryptosystems means there is a need of a largest prime number P, and we should take R as an element of ZP with cross operations. So in ZP group, the multiplications operations are performed. So in which R will be taken as an element of ZP. Then we should take E1 number. So E1 should be the primitive root of P. With the help of E1, we will calculate E2. So E2 is equal to E1 power D mod P, where D is a private key. So these are all the values that is needed for implementation of Elgamal cryptosystem. So E1 is the primitive root of prime number P. E2 is a calculated value. So E2 is equal to E1 power D mod P, where D is a private key. So with the help of these three values at initiator or the sender side, two values are calculated. So here capital P is taken as a plain text. P1 is equal to E1 to the power R mod P. Here R is an element of P. Then after calculation of C1, C2 is calculated. So C2 is equal to E2 to the power R into plain text value mod P. So there is a need of two values that will be taken as a pair of ciphertext. So ciphertext is the value of C1 and value of C2. These are all the public keys. That means E1 is a primitive root of P, E2 is a calculated value from E1. So public key pairs are E1, E2, P. At the receiver side, there is a need of creating or generating a private key D. So using the private key only, we may able to implement a decryption methodology. So select a largest prime number P. Select E1 as the primitive root of P and select any D value. So E2 is equal to E1 power D mod P. From that D is calculated. Then for retrieving a plain text, we are having C1 and C2 value. These values are received from the sender side. So the decryption methodology is C2 into C1 power D inverse mod P. So this is the decryption methodology. So using this formula, how can we able to retrieve plain text? That is the question. So I will give the solution for that. Here it is the key generation methodology. For key generation, we will generate private key D using the values of P, E1, E2, D. So using these three values E1, E2, P, we will calculate a D value. So that D value is used for decryption purpose. So this is the general key methodology. So this is the encryption formula. C1 is equal to E1 power R mod P. C2 equal to E2 to the power R into plain text value P mod P. So this is the decryption formula. plain text P is equal to C2 into C1 power D inverse mod P. For doing the bit operations, the bit operation is the most complex one at the encryption and decryption of Elgamal crypto system. So this is the proof. So decryption here, P is the decryption. So decryption P is equal to C2 into C1 power D inverse mod P. We already know that C1 is equal to E1 power R mod P. C2 equal to E2 to the power R into capital P mod P. And we know that E2 is equal to E1 power D mod P. So using these three formulas, we apply these three formulas at the substitutions of decryption side. So instead of C2, I am writing this notation E2 to the power R into P. Instead of C1, I am writing E1 to the power R. So C1 power D is changed as E1 to the power RD inverse mod P. And we know that E2 is equal to E1 power R, E1 power D mod P. So instead of E2, I am writing E1 power D into R. So that is written as E1 power RD. So the values are E1 power RD into P, E1 power RD inverse. So we may able to cancel E1 power RD and E1 power RD inverse, because at the multiplication formula A into A inverse is equivalent to 1. So for that E1 power RD and E1 power RD inverse are cancelled, and we may able to retrieve plain text. So this is the Elgamal crypto system algorithm. So let us take the problem for solving this Elgamal crypto system. So it is the example. Bob chooses the prime number P, E1 value, D value. So these three values are given. We should calculate E2. So the formula is E2 is equal to E1 power D. So here E1 is 2. So 2 to the power 3 is 8. So public key pairs are E1, E2, P. So this is the public key pair. Public key pair are E1, E2, P, prime number P. So E1 is 2, E2 is calculated, the calculated value is 8, prime number P is 11. And private key is 3. So this is the D value. It is given. Alai chooses the element R. R is an element of P. So R is equal to 4. We should calculate C1 and C2 with the plain text number 7. So the formula is C1 equal to E1 power R mod N. E1 is 2. So 2 to the power R value is 4. So 2 to the power 4, 16. 16 mod 11 is 5. So the answer for C1 is 5. So here 5 mod 11 is 5. And C2 equal to P into E to the power R. So the plain text P value is 7. So 7 into E2 value is 8. So 8 to the power R value is 4. So 8 square means 64. 64 into 64, 4096. So if you multiply these two values and if you do mod operation, the answer is 6 mod 11. So 6 mod 11 is 6. So the ciphertext pairs are C1, C2, the value is 5 and 6. And we should verify whether applying the C1 and C2, we may able to retrieve the plain text value 7. So we do the decryption process. So here decryption P is equal to C2 into C1 power D inverse mod 11. So C2 value is 6. C1 power D means C1 is 5, D value is 3. So 5 cube means 125. So 6 into 125 inverse mod 11. So 125 inverse means, how can we calculate inverse of a particular element? So one element and its inverse mod 11 should be equivalent to 1. So 125 into x is the inverse of 125. Mod 11 is equivalent to 1. So I do some calculations for substitution. If I am substituting x equal to 3, 3 into 125 is 375. Mod 11 means the quotients are 3 11s are 33, remainder 4, 45, 4 11s are, so the quotient is 34, remainder is 1. So the 125 inverse is 3. So instead of this 5 cube inverse, I am substituting 3. So 6 into 3, 18, 18 mod 11 is 7, So I may able to retrieve the plain text value. So the ciphertext pairs are 5 and 6. So in this way, we may able to do Elgamal cryptosystem algorithm for solving the encryption and decryption methodology. Thank you.